Good morning, everyone. Thank you for being here with so many of you. Again, this is our yearly appointment at Svetich. What is new in .NET and C Sharp? Uh, I'm even too lazy to call out that it's .NET 10 and C Sharp 14 because every year I'm doing this talk here. Again, very happy to be here. Just as every year, I've been spending the last year basically reading the GitHub repositories from Microsoft, reading their documentation, reading their release notes, and from that, creating for you a whole list of new features, of course, in .NET 10 and C Sharp 14. Very quickly, my name is Johnny. I'm from Belgium. If there's any questions today, you can just ask me. I will be here after the talk also. I will be here tomorrow. There's a weird QR code there generated from my browser that will take you to the GitHub repository that contains everything that I will show you today and even more. Because I only have 50 minutes, and I think there's about 3 hours of content here. So I'm just going to do as much as I can. All the rest is on my GitHub for in a specific repository for today. Are you ready? Cool. Visual Studio. So one solution, 44 projects, all the new features in .NET. I have some ASP.NET Blazor, but I'm not going to go into Blazor because that's already happened this morning. Some Entity Framework, and of course C Sharp. Let's start with C Sharp because I think those are the most fun features. Extension members. So if you look at extension methods today in C Sharp, we all know and love them, but sometimes also hate them because they look a little bit weird. Basically, we need to create a static class, and within this static class, we need to create a static method where the first parameter of this static method has the weird this keyword. So this is an extension method. This is when we want to add functionality to a type that is not ours. So we can't add a method to the type because we don't own the type. For example, a type that lives inside of the base class library for .NET, IEnumerable of int. We want to add a method to that. So we use this little trick to make sure that the compiler thinks that the where greater than one method is actually on top of the IEnumerables interface, but it's not. This is the way to do that. So because this is quite limiting, the C Sharp team decided to basically look again at how extensions are working, and they found out a new way to do it. And the new way looks like this. You still have a static class called extensions, or it doesn't really matter what the class is called because in C Sharp, we need to put everything inside of a type, inside of a class. So the class is just there because it needs to be there, but it doesn't really matter. And inside of this class, we now create a new scope, which is called an extension scope. So we use the keyword extension. And then in between parentheses, we are going to define the type that we want to add extensions to, and of course, name a variable so that we can use that variable to actually perform actions on. The cool thing about this new way of defining extension methods is that you're not only limited to methods. For example, this is the same method as before, only I put a 2 in the end, so where greater than 2. It does the same thing as the one as how we did it before, but the cool thing is that you can now add properties, also extension properties. So I can have an isEmpty property on an IEnumerable to let me know if the list or whatever is underneath the IEnumerable is empty, yes or no. So an extension property. So you can still choose to do it the old way, let's say, or to use the new way. They're not going to throw out the way we did it before. They just added a new way that is more flexible for us to use in other ways. Now, it doesn't stop there. You can still do extensions with generics. So for example, if you want to leave the generic open, you can do an extension of t for IEnumerable of t, where t is, for example, a number. And with this, you can also create extensions based on operators. So for example, I can do a plus operator for IEnumerable of t, where t is a number, for example. And then now you can just add two IEnumerables together using the plus extension operator, again, which is also cool. And maybe you've already seen, because the extension method trick should be static, and now it's not. You can now also use extensions for static members. So the operators are always statically defined using the static keyword. This is now possible. But you can even take that further. I can, for example, create an extension of t for list of t, where I create a static method called create. So you can do list of int.create to create a new list. Again, an extension method on the static level, not only on instance level. So this flexibility is now way more than it was before. So you can do all kinds of crazy things with this. And I actually like this a lot more than the previous one, because the previous one looked a little bit hacky. This one looks more like a real language feature. All right, this is extensions. Probably there's going to come some more ways of doing extensions within this way of working. So the team is, I think, thinking about this for adding some more for C# 15. And by the way, they are also looking at global methods, so you don't have to put this inside of a class, because again, the class doesn't really matter. It's because it's obligatory in C# to put everything inside of a class. For this, it doesn't really make sense. So maybe they're going to have something changing there too for C# 15, but we don't know yet. All right. Last year, I already spoke about this new feature, the field keyword. This was already new in the previous version of C#, but now they finalized the design. It was still in preview last year, which means that if you have properties, um, you have auto properties where you don't need to specify a private member for your properties. You can just add the getter and the setter, like get um, and set without any body. That worked for a long time, but sometimes you really want to do something fancy inside of your getter or your setter, and when you wanted to do that, you needed to add a private member. So for now, if you're too lazy to add the private member yourself, you can actually use the field keyword. So here, you can use the field keyword, and you can see it's a keyword because it turns blue. So whenever you expand your getter or setter using the field keyword, the private field will be created automatically by the compiler for you, so you don't have to do that. So it will get this funky name that will not collide with any of your own private fields. It's already there, just like it does with code generation all the time. And again, it will just work out of the box. The only issue, and that is the reason why they waited with making it a final feature up until right now, is that what happens if you already have a private member with the name field? Maybe you're calling your private variables field already, then we have a conflict there. And the team basically decided that if you're using the field keyword, it will always create the private member for you with the funky name. So it doesn't link to your own field if you have a field. If you want this behavior, you have a field and you have a property that's calling out your field, then you need to put the @ sign in front of that. This is a breaking change, which means if your code already uses the field with then the property that's using field, you will get a warning. And the warning will tell you that the field keyword binds to a synthesized backing field in the property. So if you don't want that, then you need to specifically add the @ in front. So to make sure to reference your own field and not the compiler generated field. There we go. So this feature is now final and part of C# 14. All right. This one is pretty simple. We can do name of and then a type, and then we will get the string representation for that type. Up until now, when using generics, you were always obligated to insert all the type parameters. They changed that, so now they can be optional, because name of list of t never prints the t type. It only prints list, so the t type doesn't really matter. So now you can leave that open. It even works when you have like multiple type parameters. You don't need to specify any of them. For a func, it's stupid because you also just have a func of t. So it doesn't really matter because it only prints the func, but now you know you don't have to specify those type parameters. That's just a little optimization there. Skip this one for now. Just going to skip the partials for now. This one is one that I like a lot. User-defined compound assignment operators. That's a mouthful. So if you create your own type, your own class, you can now not only override operators, but you can also override compound operators. And this was not possible before. So for example, plus equals, which means take the variable and add something to the variable itself, and then put the result inside of that same variable. So plus equals. So if you design your own type, your own class, for example, time range with a beginning and an end. So my talk is from 10 past 10 until 11. That's a time range. I can now override the plus equals and, for example, add an offset to that. And then that offset will be applied both to the beginning and the end time. This is now something you can do, which you couldn't do before. And this is not the only compound operator. For example, plus plus is also a compound operator. So it means take the variable, the value of the variable, and do plus one, whatever that one may be, and then add it, and then assign it to the same variable. So I decided that if you do plus plus on my time range, it will add 1 second to the beginning and the end. So you can do whatever you want with this. Doesn't really need to be arithmetic. You can do literally whatever you want. Like if you have a person, you can do plus plus on the person, whatever happens to the person. I don't know. It becomes better, it becomes smarter, it gets a child, I don't know. But you can do whatever you want. And this one is also fancy, the null conditional assignment. So we have had these null conditionals for a long time now. When you, for example, don't want a null reference exception and you are reading values from properties on types on objects. When the object is null, you don't want to do the null check. You can just do question mark dot, and then the null will propagate throughout all the properties. You probably know about this feature, but this is read only. Now they've basically added it when you want to write into a property. For example, if the customer has an order property and I want to assign it a value and the customer is null, you will get a null reference exception. So they now added this null conditional access operator here also, where I can do customer question mark dot order and then assign it with the value that returns from get current order. The cool thing is you will not get a null reference exception. If customer equals null, nothing will happen. And again, this is important for you to understand. So if you use this method, the get current order method will not be called if customer equals null. Because it's basically the same thing as on the top. First, you check if customer is null, and if customer is null, you do nothing. Else, you're going to call the get current order method and return that. The result that gets returned will be assigned to order. So again, this does the same thing, but it's now easier to write for us developers. But keep that in mind. Get current order will only be called if the customer is not null. And of course, this works if you have property inside of property, property on an object with a property with a property with a property. Just put question marks everywhere, and it will. When one of them is null, your method will not be called, and the value will not be assigned. All right, let's go up towards .NET and see what's happening in .NET. I'm not sure if many of us are going to use this, but I am going to very quickly talk about it because quantum is a hype. I also do quantum talks, so it's fun for me to talk about very quickly. Post-quantum cryptography is something quite simple, and it has nothing to do with quantum. Basically, people are telling us that when quantum computers are available or are going to be available in the future, we don't know when, but if they are going to be available in the future, they possibly can break our current algorithms for security. This can be true, but we just don't know if it's going to be in 2 years, 5 years, 50 years. Doesn't really matter. The point is that we have been creating new algorithms that are stronger and that are better suited and that quantum computers in theory cannot break. These algorithms are being worked on still today, and they are being integrated into all of our IT systems, and .NET will now add a couple of classes for us to use those algorithms because they are there and developers need to be able to use them. So that is what this is. So post-quantum cryptography just means new cryptographic algorithms that can be used in the post-quantum era when quantum computers are actually available. And there's 3 algorithms. There's MLKEM, MLDSA, and SLHDSA. So these are just 3 new asynchronic cryptographic algorithms. You can use them. The classes are available. They have static methods on top of them to create, to encrypt, to decrypt, to do all kinds of cryptographic stuff. And you can even check if your current system supports these new algorithms, because these algorithms are implemented on the operating system level or even on the hardware level. So you can actually check within your source code if your operating system and hardware supports these algorithms, and if they do, you can use them. For example, in Windows 11, they have been added, all three of them, since the last big update for Windows 11, the end of last year. So I did this talk for the first time in September. They were not available then, but I did it again in November, and then they were available within the latest patch of Windows 11. That's it. What's next? I'm gonna talk about numeric ordering. This is also something that I like. So if you have some objects and they contain properties that have strings, and you want to order by string, but the string is a number, like for example the version of C#, you can now order in a numeric way if it's still a string. So you can create a string comparer, and there's a new compare option called numeric ordering. And if you use this, your strings will be ordered in a numeric way, which means that, that 9 and 8 will be smaller than 10, 11, and so forth, because it will look at it in a numeric way. Before it would be alphabetical, which means that 10 would be less than 8, because it's 1 in the front and 8 is more than 1. So that's the change. This is quite handy if you want to do something like that, like file names in File Explorer, stuff like that. This new feature would arrange them by numeric number and not just string. I'm going to talk about this one because I found it a little bit funny and weird. So there is a method, a static method in .NET for a long time now, and it's timespan.from milliseconds, and it has two parameters. So it gets a number of milliseconds, but also a number of microseconds. And the result will be a time span that is a decimal of milliseconds, because you also have microseconds. Now the problem with this is that microseconds was an optional parameter in the previous versions of .NET. What that means is you don't have to provide a value for it. If you don't provide a value for it, it will be 0. So the default value for that parameter was 0. But you can't use optional parameters within a lambda expression. Lambda expressions don't support optional parameters. So you couldn't use that method in a lambda expression. The team found out, and they basically, in .NET 10, created an overload instead of an optional parameter. So you can just have one method with optional parameters, or you can define your method multiple times with different overloads, which does the same thing, but syntactically is a little bit different. And now it will work in a lambda expression because now they created the overload. So if I change my version of .NET for this project into .NET 9, you will see that it gets a red squiggly line here in this lambda expression, because it can't use that because it has optional parameters, which is not allowed in lambda expressions, which is something that I did not know. But now you know, and if something goes wrong, you know why, and you know how to fix it. I'm gonna skip this for now. This is something that I find interesting just to repeat, because I see that a lot of people don't really know about this. There's a class in the base class library called the ordered dictionary. And if I ask people what is an ordered dictionary, a lot of people say, oh, it's a dictionary that you can sort. False. That's a sorted dictionary. So there's a sorted dictionary, there's an ordered dictionary. What's the difference? The sorted dictionary can be sorted. The ordered dictionary, the only thing it adds to a regular dictionary is that you have a concept of index, the index of an item, of a key value pair. So in ordered dictionary, you as a developer, you can actually use that index for in some cases, some algorithms, it's nice to use a dictionary that also has indices. So that's what the ordered dictionary is for. So it doesn't sort. But they added a couple of methods and overloads to the ordered dictionary so that you can actually work better with these indices. So for example, when you do try add to add a key value pair to your dictionary, it now has an additional parameter, which is an out parameter index, and it will return to you basically the index where it added the item. It's going to be added at the end, but now you know what the index was for that last item, and you can keep it, and you can do stuff with that in certain algorithms. Now, it's of course a triad because when the key already exists, it will fail, the triad will return false, and the index will not return an index, or it will return the index that is already available for that item. There's also try get value, which does the same thing. You try to get the value for a specific key. If it finds that value, you will get the value itself, but also the index where the value lives using the out parameter. So this is new. Maybe this one is also interesting to know. If you're using zip files and zip archives from .NET, they did a lot of work regarding performance. So the APIs didn't really change, but they did a lot of internal optimizations. Um, Basically, if you look at the numbers, I have the results for a benchmark right here. So in .NET 10, if you especially if you look at allocations, you have, like, for example, in my specific case where I have large files and I'm adding files inside of an existing zip archive, large files. You can see that in .NET 9 it would take 4 gigabytes of memory. In .NET 10 it only takes 1 gigabyte of memory. The reason for this is very simple. In the older versions of .NET, it would load the entire archive into memory, add an entry to that, and then write it back to disk. Today in .NET 10, they optimize that, and it will not read everything to disk. It will only add that item and only add that single entry to disk immediately inside of the archive. So it doesn't read everything and write everything. It only writes the changes you make. So this is a lot faster, and it takes a lot less memory to actually change existing zip archives using the zip entries. The thing that they did change with the API itself is that it now supports everything in async. This was not yet the case. So if you want to create zip files or read from zip files or do anything with zip files, they now all have async variants, so you can actually use your await to do this asynchronously, which is nice. So no additional methods or additional features, just the fact that you can now use async. This one, I'm going to be honest, is something that I did not know already existed. So if you use JSON serialization and deserialization, and I have, for example, a class called employee. The employee has a name and the employee has a manager, and I'm creating an instance for myself, and I'm going to put myself as my own manager. At least that's what I'm trying to tell my partner at home. Basically, what I'm creating is a circular reference. And if you try to serialize this to JSON, by default, it will just start serializing it. It's like manager, okay, the manager is Johnny, it has a manager, oh, the manager is Johnny, okay, it has a manager, the manager is Johnny, and it just keeps on going. You've probably seen the exception that after 64 times it just stops, throws an exception, like, okay, I don't know where this is going, but I'm going to stop it right now. You can put a maximum to that, like you can put a maximum that it will stop after an amount of time of operations, but there's something called a reference handler. So in your JSON serializer options, you can add a reference handler and you can set it to preserve. And if you run your serialization like this, and again, I'm going to be honest, I did not know that this existed. It creates a JSON like this. It basically gives your object an ID, 1, and then it says the manager references to ID 1. And this is completely valid JSON. You can also deserialize it back into objects, and then the objects will actually have that reference, which is pretty cool. Now, the problem, because this already existed before, the problem with this is that it works for JSON serialization out of the box, but we also have support for source-generated JSON serialization and deserialization. This is a feature that's been added a couple of years ago, where instead of doing in-memory dynamic code to serialize and deserialize strings into objects, they basically created source generators that can do that for you. And why source generators? Because in ahead of time compiled machine code, we can't do dynamic code. It can only be static code. And with the source generators, it will create static code for your specific use case. So you've created an object called person. The source generator will create the serializer and deserializer for your objects, for your classes, and that can be statically compiled into machine code, ahead of time compiled, and it doesn't need any runtime. It doesn't need any runtime knowledge, or it doesn't need any dynamic code. So that is cool. But they forgot to implement the fact that you can have reference handlers. So that was not part of that. So now they just fixed that. They added the concept of reference handlers to your source generated JSON. So if you're using source generation today for JSON, you can now also use these reference handlers, and also put them to preserve references when deserializing back into objects. Just a quick question: who has no idea what source generation is? You can be honest. Okay, I see a couple of hands, so very quickly. So a couple of versions of C# and .NET ago, they added source generation, and they've been creating source generators for more cases, where they want to get rid of the dynamic code and really make it into static code. If you want to learn more about source generators, for example, in this case, I'm using source generation for JSON, which means that if I want to have source generated JSON for my object, I need to create a class that's called context, and it derives from JSON serializer context. This is a class in the base class library in system.text.json. This is my class. I don't need to have anything inside of this class. This class is partial, so the content of the class will be automatically generated by a source generator, and I need to add the attribute JSON serializable for my type. So for my employee type, I need to have source generated JSON serializers and deserializers. Now, if you go to your project dependencies, um, and analyzers, you will find an analyzer called the JSON source generation. If you open this, and again, you will see some C# files. And they have the extension .g.cs, which means generated C#. This contains the source generated code for my employee serializer and deserializer. You can open it. You can put breakpoints inside of this. You can run your code. The breakpoints will hit. You will see what happens. This code is automatically generated by a source generator. You can't change this code. Lives in memory. It does not live on disk. It does not get committed to your Git repository. It's just in memory. The compiler will regenerate it every time you compile. This is basically the answer to designer-generated files that developers would always change. So you can't change this. Bad developer. Um, so that's the idea. And they're creating these source generators for all kinds of things, in order to be able to immediately compile down to machine code instead of using the intermediate language and the .NET runtime stuff. Because the .NET team is going for performance, 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 and they really want .NET to be the most performant platform out there. All right. Next one, option to disable duplicate JSON properties. So they're also doing a lot of things with the new JSON serializer, so system.text.json. And the thing that they added is that when your JSON has multiple properties with the same name, before and still today, by default, doesn't really matter. If you have length and then again length, the last one will always win, because it just deserializes property by property. So length equals 1, okay, and then it continues, and then it sees another length. It will just override the previous one with the new value. So okay, there's length -1, okay, it's going to be -1. Maybe for some reason you don't want that. Maybe for some reason, if this happens within your JSON, you think like, okay, this is not valid. I don't want to continue with this. There's a new property in your JSON serializer options called allow duplicate properties. And by default, it's true, which is a bit weird, but you can set it to false. And if you set it to false, it will throw you an exception. If you like your exceptions and you have twice length, then it will throw you an exception, because you can't have multiple properties, duplicate properties, that is. And with that, it's a new option on top of already existing options. For example, in the past, we already had things like unmapped members and disallowing the fact that there are unmapped members. What does that mean? If your JSON string has a property that your object does not have, by default, nothing happens. It's like, okay, I need to deserialize length, but there's no length property on your object, then fuck it. We're not going to deserialize, we're just going to skip it and we're going to move to the next one. There's a disallow policy that you can also set to true, and then it will throw an exception when that happens. Case sensitivity, so by default there is no case sensitivity. If your property starts with uppercase, but in your JSON it has lowercase, it will just map those two properties like nothing happened. Again, you can enable case sensitivity, and then it will throw an exception. Respect nullable annotations. When you have on top of your object an integer, for example, and there is no property that corresponds within your JSON string, nothing happens. The integer will just have the default value of 0. When you put this respect nullable annotations, it will throw an exception. When you have a nullable integer, then it will work if the property is not there. But if the property is there and the integer is not nullable, then it will throw an exception. And it's the same for constructor parameters that are required. It's very similar to the previous one, but then for constructors. So all of this options that you can set and that you can change, they are now all part of also a new constant, which is called JSON serializer options.strict. So if you want to fuck around with your colleagues, just put this into their JSON deserializer. Just put everything to strict, and then it's going to be exception galore, because everything will fail. I'm going to skip this one for now, and then I never needed it, but apparently some people do, which is perfectly fine. But we have in link now left join and right join. So purely link, so memory, in-memory link now has left join and right join, and it just works like you know it from SQL. So for example, I have a list of people, I have a list of addresses. They don't have references directly, but they use the ID pattern like ID 123, and then the address is linked to a person by person ID. I can now do people.left join to do a left join, which means I'm going to join addresses to people by doing a left join, where the person has the ID, the address has the person ID, then it will give me a tuple of a person and an address by using this join. And then I already know that all the persons will be there, all the people will be there because I did a left join. So there's always going to be a person, but then optionally there's also going to be a city. So some people are linked to a city, but if no link could be found, then address will be null. That's a left join. And then you have the same thing for a right join. Again, addresses to people. The person has an ID. The address has a person ID. You get the tuple person and address. So we use the same order. But now we do a right join, which means that the addresses will always be there. So there's always going to be a city. But the person can be optional. So if no person has been found, the person is going to be null. I can use an unknown value. Otherwise, we can use the name of this person. So left join and right join now for you to use in link. This, of course, applies also to entity framework. So if I scroll down, there's also some new entity framework features, and this, of course, also now has left join and right join, which is a lot simpler than what you needed to do before. Before, you could use link to SQL to do a left join and right join, but you needed to do like select many, group join, and default if empty. So it was kind of a complicated construct, and that would be translated and do the same thing as a left or right join. But now you don't need to do that anymore. You can just immediately use left join and right join on your DB set, on your DB context, and it will now get translated immediately to left join and right join in SQL, of course. All right. Now that we're into Entity Framework, there's a couple of cool things in Entity Framework 10 that I wanted to show you. The first one, of course, with all the AI hype going on, nobody here from Microsoft, I hope, it's vector search support for Entity Framework. So also, since not so long, They have added a vector support for SQL, Azure SQL and SQL Server 2025, where you can actually store embeddings as vectors within your SQL database. You don't need a vector database, or you can use a vector database, but now SQL Server also has support for that. And Entity Framework now also has support for that. So, who has no idea what an embedding is? Okay, a couple of you. So basically, if we look at Gen AI and large language models, um, for example, when we look at text strings, text can be a name or it can be a sentence. We can use language processing and language models to create a mathematical representation of this text. That's basically also how large language models work. What happens is a vector will be created that kind of describes the features of your piece of text. So it can be an article or a comment from somebody. You basically create a vector in a vector space, and this will align with whatever is going on in that text or in that word even. Um, if you really dumb it down, for example, you take a vector in a two-dimensional vector space. We all know that a vector in a two-dimensional vector space, x, y, there can be a vector somewhere there. If you have the word cat, that can be represented by a vector. If you have the word dog, that can also be represented by a vector. And the vectors for cat and dog, they will be kind of similar. They're not exactly similar, but they maybe point in the same direction because cat and dog are both animals. They're animals that are pretty close together because people love them and people have them in their homes. So this is like the way we think about words. This is okay. Cat and dog are quite similar. If you have ice cream, that will be a vector pointing somewhere completely different because ice cream has nothing to do with dogs and cats. And that is actually how we compare words to each other. And this is quite handy if you provide search functionality. So if people are searching for a word, we can actually search for very similar words by using vectors, by using embeddings, and this is what that is. So if I create a database, for example, that only contains first names, so these are around 600 first names, I can generate using a large language model or a small language model, I can create an embedding, which is a vector in an n-dimensional space. It will store all of these vectors, which is now a native type in SQL Server. And I can use Entity Framework to search for names that are similar, for example. By the way, I gave you an example of a two-dimensional vector space. Actually, here in SQL Server, this is a vector space with 1,998 dimensions. So have fun with that if you're a mathematician. So that is how we store these embeddings. And then in SQL Server, um, you can create a query. For example, here, I have a list of first names or a table of first names, and I'm going to order by, and this is a new Entity Framework function that gets translated to SQL called vector distance. So I have the vector or the embedding for each name in the database, and I also need to generate the vector or the embedding for the thing that I'm searching for. So here I'm searching for all the names that are similar to Johnny, my own name, and I'm going to use an embeddings generator for that. This you can use OpenAI for this, or I'm using a local running version of Olama to run my models locally. That all works. So now I'm creating a vector for Johnny, and I'm going to compare it with everything in the database. I'm going to take the top 5 names, so the 5 names that are most similar to Johnny, and I'm going to return them. And if I run this, maybe I should have ran this and then did all of the explanation because it takes some time to find this because I'm running it locally on a local model. Um, so I'll show you again very quickly the code. In the top, I'm using the Olama API client, which is something you can get from a NuGet package, the Olama Sharp and the Microsoft Extensions AI. So I'm using this to connect to my local Olama instance. And then I can use an embeddings generator, which has the same amount of dimensions than the ones that I'm storing in the database. And then, as I told you before, I'm generating a vector for Johnny, and then I'm comparing this vector to the vectors that are already in the database. And then I get Johnny, of course, my own name is closest to my own name. And then there's also Jimmy, Jeremy, Joe, and Jake, which are quite similar And this is something you can, for example, can use for comments or articles. If you have a complete article, create all the vectors for it, and then if articles are quite similar, you can use this to check how similar they are. Pretty cool, I think. What else do we have in Entity Framework? Yeah, JSON support is something that was already there. So you could actually have a property in your objects that is a sub-object, so that's a complex type. You could store that as JSON in the database if you didn't really want to put it like in a new table with columns for all the fields. You could just have it as a blob in JSON. The only change here is that in SQL Server, JSON has always been like a string type, an envarchar. So it would store JSON as strings. And today, with the new version of SQL Server and Azure SQL, they changed that and they have now a native dedicated JSON type. Why? Because they can now do queries within this type. So for example, if I have blogs and my blog has details and my blog details, that is a JSON object that actually sits in a single column. So by the way, if you look at the DB context, um, the entity blob has a complex property details, and this is to JSON, which means it will be stored as a JSON, and now in the new version of SQL Server as a JSON type. You can now also do stuff like, okay, give me all the blogs where the tags contain entity framework 10, and the details dot viewers is more than 10. And this is a query inside of your JSON. And then SQL Server will now be able to cope with that because it also internally stores it as JSON, but as smart JSON, not just a string, and it can actually query inside of that data, which is nice, which is cool. So that's the change there. I'm going to talk about this one because this blew my mind, not because it was super complicated, because it's just super weird. You maybe know this, but if you write SQL queries, for example, through Entity Framework, and you use a where-in clause, where-in is pretty difficult for SQL to cache. So SQL uses a lot of caching. If you do a query multiple times, the query will be cached and will be optimized so the query runs faster. But if you use where-in, each of these parameters is probably going to be different. It's not always going to be the same collection. And the first step that they did was, okay, if the numbers are not equal, then we have a problem. So we create these into parameters. And if you create parameters, then if you, for example, call the same query that has 3 parameters multiple times, the values of the parameters don't really matter because caching happens on top of the parameters. So 3 parameters will always be 3 parameters and that query will be cached successfully, which is nice. But if you change the number of parameters, like 3, sometimes 5, sometimes 6, then again, we have an issue because the query cannot be optimized. Now, what did these little .NET buggers do? Something very funny. Let me run this for you and have something to drink because I'm doing all the talking. All right, I'm running a query with 2 parameters. What's the result? Where-in 2 parameters. Fine. I'm running another query with 4 parameters. What is happening? I can see 4 parameters. All right, nothing funky going on. Now I'm running another query with 8 parameters. What am I seeing? 10 parameters. What the fuck? All right, let's look at the values for those parameters. 1, 2, 3, 4, 5, 6, 7, 8, 8. Okay, 3 times 8 at the end. That's because I called it with 8 parameters and it filled it up to 10. And it just repeats the last parameter because functionally it doesn't really make a change. It doesn't really matter. But internally, you now have 10 parameters. 10 parameters will be cached. And if you call it with 7 parameters, it will just fill up the remaining parameters with the same value. And you can see it when it happens, what happens when I do 11 parameters. It just uses 20 parameters. And you can see 11, 11, 11, 11, 11, 11, 11, and so on, which I found funny. So this is now a new feature in Entity Framework 10. So by default, it will just have like a certain offsets, like 2 is 2, 4 is 4, everything in between 4 and 10 will be 10. Everything in between 10 and 20 will be 20, and so on. I didn't test it further. I don't care, but I just found it pretty funny. By the way, I needed to do something extra to show you these values because by default, and this is also new in Entity Framework 10, by default your parameters will be not shown to you. So you can see here it's just all question marks. So if you do some logging for your internals in the past, your parameter values would be inside of your log because they would be logged because they were part of your query. Now it's completely redacted by using question marks, so you don't see the actual values, which is nice for privacy purposes. So by default, you can't see that. The way to actually do make sure to, if you want to see them, it is what I did here. Is enable sensitive data logging. If you use this on your option builder, you get the actual values in your logging, so you can get to the sensitive data if you want that for some reason. You can still enable it, but by default it's disabled. All right. I only have 5 minutes remaining, so let's see if we have some more fun things to talk about. I'm not sure if it's completely irrelevant for people, but I started doing .NET in 2003. I started in WinForms. Sometimes I still like WinForms. Am I weird for that? But do you see this? WinForms now has dark mode. I'm not kidding. It has a property on the form. It's now dark mode. It's beautiful, isn't it? Something else that is new in WinForms. This actually blew my mind. I'm not sure if I'm ever going to use that, but so you know this from Android and iOS. If you take a print screen from your application, it just works. But now there's a new property on WinForms, on your form itself, where you can hide your content when somebody takes a print screen. See, it turns black. So if you have some privacy data on your WinForm, you can now make sure by just changing this property that people can't take screenshots. Of course, they can still take out their phone and take a photo from their screen, like a real boomer. But the third option is even more magical: hide window. And if they do that, the window is just gone. It's like it's never been there. This is something that's already available in the Win API, Windows APIs for a long time, but they now just made sure that you could use that from WinForms very easily, which I thought was amazing. All right, 3 more minutes. What else can I tell you that is quite cool? This is something I had no idea that existed. Again, I've been doing .NET for so long, and this always skipped me. So pipe, there's a system.io.pipeline, so you can actually create anonymous and named pipes. A pipe is it's just like a pipe, but no water runs through it or gas. Data runs through it. So you can actually use pipes between processes on the same computer or even in a network. So anonymous pipes can be used inside of your process or from your process to child processes, and named pipes can be used in between processes that live on different machines within the same network. So not through the internet, but in the same local network. You can use this because it's a very fast way of delivering data. For example, sending events within processes on the same machine goes very quickly, so it's very performant. And the thing that they changed with pipes is that it now has standard support for JSON serialization. So a pipe has a reader and a writer. So you have a pipe and you have both ends. At one end you can write stuff in the pipe, and at the other end you can read stuff from the pipe. It's binary data by default, so you have a pipe reader and a pipe writer. But now they made sure that the JSON serializer and JSON deserializer, they are now compatible with pipe readers and pipe writers, so you can immediately put JSON through your pipe. So for example, here I'm using a pipe writer, and I'm going to serialize asynchronously into my pipe writer, and I'm going to get my data from an iasync enumerable. So I've created a class chunk, which just keeps a piece of text and then a date, and I'm just going to return some of these chunks as an iasync enumerable, and I'm just going to put it JSON serialized within the pipe writer. And then at the other end, I'm going to create a pipe reader. And I'm going to deserialize asynchronously with an iasync enumerable. So again, chunks go in, get serialized in JSON. So JSON through the pipe. And then at the other side of the pipe, they will get deserialized again back into my chunk object. And I can work further with that. So you can actually use pipes with your own objects, put objects in the one end, and they will come out at the other end, of course, serialized as JSON within the pipe, which I think is pretty cool. All right, I think that's it. Of course, I skipped some of these things because time is running out and I like to talk. So if you want to see more, this is the QR code one more time. This complete solution is in my GitHub repositories for you to have fun with. I don't really care what you do with that. You can do whatever you want with that. Thank you so much. Enjoy the rest of the day and of course also tomorrow. Thank you.